Okay, this is our third and final section in Chapter 6. We'll be covering polar coordinates, but please note that we are not doing polar equations. We're not graphing the equations, we're simply plotting points. What does the polar system look like? Well, here we go. We are used to the XY coordinate system, and the polar coordinate system also has two components. It's just that they are r and theta instead of x and y. And you'll need to write down your definitions here. R is the directed distance, so there's a direction element involved, but it's the distance from O to P, and O is where we're starting and P is where we're ending. And it's the initial ray that connects those two. Now the other part is theta, and it is the directed angle, and we're going counterclockwise from the polar axis to that segment. So you can pause for a second if you need to finish writing those down. Let me show you a picture though. So if this is my polar axis right down here, and if I have this as my point O, and my point P is out here, if I go from O, which is at the origin, out to P, that point right there is r, comma, theta. The r is the length of that ray, and the theta is how far the ray has rotated from the polar axis. So here's the theta. And as we go through some examples, it'll click a little bit more, but that's a great picture to have. Let's move on. All right, here are some coordinate conversions that you're going to need to write down. They'll be incredibly important to us, especially later on. We also need to maybe take a look at a picture just to help these make sense. You can pause whenever you need to. But when we first started trigonometry, before we even went to the unit circle, we said, well, what if it wasn't a unit circle? What if we had a radius of r? And we made this right triangle. And we determined that this point would be r cosine theta, and this is r sine theta. It's just an enlarged version of our unit circle, a point that would be on the unit circle. So the x value is the same as r cosine theta, and that's where we get this. And the y value is the same as the r times the sine of theta. Our theta is in here. So that's where these two primarily come from. And then the other two are pretty natural to follow. You have the tangent is y over x, which also means that you've got the tangent is sine theta over cosine theta. The r's reduce. And then here's the Pythagorean identity for these guys. And there you have it. We'll be using those in doing conversions of not just points, but also equations. So keep those handy. These are things you're going to need to know by memory. So get those in your head. Okay, plotting a point in the polar coordinate system, pretty simple. There are two ways to do it. You could do the radius first and then the angle, or you can do the angle and then the radius. It's not as easy to confuse as XY coordinates. So we're going to plot the point and then find 3 additional polar representations of the point. So you can represent a single point in more than one way. For example, if I've got the point 1 and 7 pi over 4, so this is the radius and this is the angle that I need to turn to. I almost always turn to the angle first and then do my radius. So I'm going to find 7 pi over 4. And these are a little difficult to see, but I'm going to kind of mark out my pi over 4s. I'll do it in green. So there's a pi over 4. Here's a pi over 4. Here's another one. So there's 1, 2, 3, 4. And then 5, 6, 7. All right, so 7 pi over 4 is down here. Let's pretend for now that this radius all the way out to here, let's say that that radius is 1. So we go all the way out to the outside, that's 1. You can adjust that to whatever you need it to be on your polar graph. However, I'm going to turn to 7 pi over 4. So I'm going to go around to 7 pi over 4, and then I'm going to stop. That's where I need to end up. But I need to end up way out at 1 down here. Okay, I'm going to call this point A. Okay, so this is point A. It's directed to 7 pi over 4, but the point is out 1 unit from the origin. Now, what are some other points that could also get there? How else could we tell somebody to get to that exact point? Well, we could say that it's out 1, but instead of going counterclockwise, we could think of this more of a rotation down this way, and that would be negative pi over 4. Okay. Now here's another thing. Instead of a radius of 1, and this is kind of strange, but we could tell someone to use a radius of negative 1. That means that they're going to turn a certain direction and then go backwards. So if I take this dashed line and I extend it out here, wish my smartboard was aligned very well today, then I can actually turn this way. I could turn this way, which is only 3 pi over 4. So I'm facing off in this direction, but then if I back up negative 1, put it in reverse. Okay, when you see that negative 1 there, think of putting this in reverse. So if I turn and face this direction, and then I back up 1 unit, I would still get to that point. This is a lot better explained in person. And then, of course, another thing that we could do, let me finish that one first. This is 3 pi over 4. So basically, this ordered pair says turn to 3 pi over 4 and then back up 1. Now you could do it with the negative angle as well, so that we could do negative 1, and then we could do a negative angle. So if we have someone go all the way over this direction, this negative angle, that's negative 5 pi over 4, and then back up 1, they would still get to A. So this would be negative 5 pi over 4. So basically when you're doing these, you want to plot the initial point and then think, okay, if I use the same radius and go the negative direction, that gets me 1. Then take your initial ray and make it go the exact opposite direction. Just extend the line out like we did here. We extended this out. And then think about backing up to it. That means you have a negative radius. And then do the positive angle measure for that, and then the negative measure for that. Okay, now I'm going to erase my stuff on this and show you the next one. This one's negative pi over 6 in direction and negative 7/8. So if I'm going negative pi over 6, and then I back up. So pi over 6 is going to be down this direction. So there's negative pi over 6. However, I have a negative radius, so I'm backing up. So I initially got to here, but I'm going to be going the opposite direction. So I would be facing this way, but I'm going to back up to 7/8, and each of these is 1/8. So I've got 1, 2, 3, 4, 5, 6, 7. So right there is my point B. So I went down to pi over 6 in that direction, and because this was negative, I backed up, I put it in reverse. Now what are some other points that would coincide with that? A different representation. Well, let's keep the negative 7/8 at first. So backing up, we have the negative pi over 6, or we could think of it as not the small negative angle, we could think of it as going all the way around to 11 pi over 6, and then backing it up. Okay, go all the way around to 11 pi over 6 and then back up to 7/8. Or we could go this route of doing a positive 7/8. And if we go positive 7/8, that means we actually want to be facing this direction when we turn. So if that's the case, I could be thinking about this angle, or I could be thinking about this angle. That one is 5 pi over 6, and this one's 6, 7. So this is negative 7 pi over 6. So those are my other two positive angles. So I have positive 7/8 with positive 5 pi over 6, and then I also have 7/8 that's positive with a negative 7 pi over 6. Give yourself a minute to look through that, think through it,